Our last talk will be by Calum Robson from London School of Economics, and this will be on the role of relationality in physics.
Okay, well, thank you. And so my talk is going to be on the role of relationality in physics. And I think I chose the topic based partly on an email exchange, I think, between myself and some of the people at Helsinki on the dynamic universe on this topic. So I was going to engage with some of that here. My talk's got, I think, 7 parts. So first of all, I'm going to talk about 2 different kinds of relationality. So I'm then going to talk about where I think the relationality in Bohm's theory comes from. So I suspect it might have something to do with Bohm's early Marxism. I'll then go on to the implicate and explicate orders and talk about them as a kind of relational ontology. There'll be a brief interlude to look at some Hamiltonians before I think I'll start talking about semiotics and how relationality relates to image, how images can be seen as sort of relational. Finally, I will look at the idea of absolute space. And I'm going to argue that Newton's absolute space is possibly linked to his Arianism, which as in his views on the Trinity. And I should be clear here, I'm not trying to make an argument for or against absolute space, only to talk about how Newton might have come up with those particular ideas. And then finally, I will talk about how relationality is linked to the dynamic universe. I think on that today, I'm sorry, I think my comment was a bit rude earlier, so Ketch, I'm sorry, that was a bad way to make the point I was trying to make. Wrong way. Okay, so there's 2 sorts of relationality I think, in physics in general. There's what might be called perspectival relationality, and there's what you could call dynamic relationality. And so I'm taking the basic idea from this paper by Emily Adlam, I think it's in Pittsburgh, what kind of relationality does quantum mechanics exhibit, but I'm applying this not only to quantum mechanics, but to other physical theories. So perspectival relationality is where there's no change in the system being, in either system, it's just a change in the way the systems are being viewed. So if you're looking at a statue and you walk round the statue, your relation to the system, to the statue changes, and your description of the statue changes, but neither you or the statue change. In dynamic relationality, when the mode of interaction between you and the object changes, in principle, one or both of the constituents. So if you are measuring the temperature of water in a pan, technically, the heat has to go into the thermometer, so you're changing the heat of the pan whilst you're measuring it. Now, in practice, it doesn't matter, but if you go down to the quantum level, it does matter. You can no longer measure something without changing it. So your measurement is no longer gives you the previous value or a past value of the physical quantity. It measures the value as a product of the interaction between yourself and the thing being measured. Now, classical physics tends to use this perspectival relationality. We have the Galilean group of symmetries. So physics is invariant under translations, under rotations, etc. I would say that any gauge theory is also using a perspectival form of relationality. Special relativity is relational, as we saw in Hamish' talk, under all of these very complicated hyperbolic transformations. But still, any 2 viewpoints in special relativity can be mapped one to another. So it's a change of perspective and not an ontological or dynamic change. In a gauge theory as well, 2 very different descriptions are linked by a transformation. The difference in a gauge theory is that the transformation changes at every point, whereas in the transformations that we've seen, like these are global, the same transformations apply to all points. So special relativity and classical physics tend to use perspectival relations. Quantum mechanics is unique in using dynamic relations. If you measure system A in an up-down direction, system B in a left-right direction, there's no transformation between those two systems. You've changed both systems by the act of your measurement. And of course, you could measure both systems again in the same basis, but then you're creating two new outcomes. You're not getting back what you had beforehand. Okay, so now on to the second section. So process in Dave as is a key part of the Bohm-Hiley approach to quantum mechanics. And so it's not a huge part of Western philosophy and science in general, with the exception of certain trends in the 19th century, particularly in German idealism. So you have this idea in Hegel of a history of the process of the unfolding of spirit, and these sorts of ideas pop up in lots of different places in the 19th and early 20th centuries, finishing with people like Ellington and that, I think. So you see, I'm afraid in this section, Engels hasn't quite appropriated the means of punctuation because he is, this is all one sentence. But the point is, the great basic thought is the world is not to be comprehended as a complex of ready-made things, but as a complex of processes, in which the things apparently stable, blah, 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 go through an uninterrupted change of coming into being and passing away. Yeah. So this, I think, is familiar from the Bohmian idea of process ontology. And I think when Bohm was a young man, he joined briefly the Communist Party, and whilst I get the impression he regretted this when he was sort of, when he was older, I wonder if being steeped in this idea of history of the process and in the dialectic materialism of Marx and Engels could have had something to do with his later attitudes towards quantum mechanics. Okay, so what were those attitudes towards quantum mechanics? So we have here, the key thing, I would say, is the implicate and the explicate order. And the idea is the implicate order is the whole process of the universe. It, in some sense, is undivided. It's a single thing. But because it's a single thing, it can't be understood fully. Partly because we are part of it, and by the act of trying to understand it, at best, we are understanding it, all of it apart from us. The explicate order is the part that we are understanding. It's the part of the universe that we orientate ourselves and interact with in such a way as to make it intelligible. So an example would be, example of the process things always work best from biology, I think. So sadly, we're not dealing with a sea slug on this occasion, or a flatworm, where, so think about the heart. Now, the heart forms part of the human body, but to think about the heart, we have to consider it as a separate entity. Now, the heart, considered in itself, includes a large amount. The heart's behaviour is determined by the entire body, so the brain, the nervous system, the lungs, the digestive system, everything else. When we focus on the heart as a thing in itself, we have to abstract it from its place in the entire process and look at it as an entity, as an object, sort of separated from the other thing it's part of. But if we don't do that, we can't understand it because, you know, we aren't even looking at it, we're just looking at the whole system. This is an example of the contrast between the implicate and the explicate order. And of course, if we remove the heart from the body, then you have an even more of a problem. You then have a kind of disconnected system that isn't having even part of the same process. But we see that the more we disconnect the system from the process, the more we can understand some parts of it, but the less we can understand other parts of it. So in general, both the implicate and we have a continuum between total separation and total continuity, and different points on the scale give us different levels of insight. I suspect this is partly why Bohm's theorem is similar to the de Broglie theorem. So in de Broglie's interpretation of quantum mechanics, we have both a particle and an attached wave. And I would suggest this is an idealization of the implicate-explicate process. The particle represents the epitome of the implicate order. It's a single disconnected point with no intrinsic relationality to anything else. The wave, on the other hand, is intrinsically connected. It's about information and about the interaction of the object with its surroundings. So I wonder if what's going on there is the particle is simplifying the idea of the object itself in the explicate order, and the wave is carrying information about it, is carrying the rest of the information in a simplified form. So the Bohm wave is another way to cash out the implicate explicate order. So this brings me on to this Hamiltonian interlude. So this is William Rowan Hamilton at the top of the slide. So the Hamiltonian, if you're not familiar with the Hamiltonian, it describes a system, and you can split up a system into different parts, and each part will be described by a different part of the Hamiltonian of the full system. So given a Hamiltonian describing some object, say, we'll call it an implicate order, but imagine it's an order we're outside of, so we can see the whole thing. So we have, if we take out an explicate order, so part S1 or S2, there will remain both a part of the Hamiltonian related to the background, to the bits we've missed out, but also a part of the Hamiltonian related to the interaction between the systems and the backgrounds. This is kind of a step beyond the Bohm case, where the particle would be the S1 and kind of the background and interactions were all contained in the Bohm wave. So when are these the same? And so sometimes these will give the same description, other times they won't. And I would argue they're the same if there's a perspectival relation between these two descriptions. So, for example, if my theory is translationally invariant, then if I choose two systems which are only separated in space, I should be able to apply the same transformation as spatial translation, the opposite translation, to both of these Hamiltonians to get the same results back again. And again, if my system is rotationally invariant, and I pick two systems that are the same but are different rotations, I should be able to rotate back from one Hamiltonian to the other and get an equivalent description. In a more complicated case, if I have a gauge theory, then two Hamiltonians in different gauges will describe the same, will describe a perspectively related set of systems if I can apply a gauge transformation to get from this description back to this system. If I can't do that, then I will not. Then there's at least they might be related, but the relation must be dynamic if they are related at all. Okay. Now, a puzzle here, this implies, is what about gravity? Because in gravity, the gauge transformations are diffeomorphisms, and you can relate almost any two functions via an appropriate diffeomorphism. And this is the entire issue with Hamiltonian gravity and why it's so difficult, because you can pretty much relate any Hamiltonian just to a constant, and at this point, it becomes rather hard to have a well-defined theory. Now, you can overcome this. Dirac came up with his constrained Hamiltonian theory, but yeah, this links back to one of the, we've been talking about gravity, and one of the major challenges with coming up with a quantum gravity is the difficulty of defining Hamiltonians that aren't just diffeomorphically invariant to like a flat background. Okay, so now we're going to get on to something maybe a bit more esoteric. I've been talking about the implicate and explicate orders. So I'm going to do a slight sidetrack to talk about semiotics and how things image one another. So this is the main thing, this diagram here, and this is kind of going back to C.F. Peirce, who was an American mathematician and logician in the early 20th century, and he has this threefold sort of idea of how semiotics works. You have the object we are trying to represent, you have its representation, and then you have the process whereby you assign sort of the representation to the object. So you might have a object, you might have a word in a language, but if you don't know the language, or even the alphabet, this will be a bit useless. It has to be a process whereby you connect the object to representation. Now, we were talking a bit about the problems with logos as sort of being limited in terms of its ability to represent the world. And logos is itself representation. And one of the themes of postmodern philosophy, I think, is precisely the failure of any representation to fully capture the reality of what's being represented. So this is kind of summed up by this chap up here, Derrida, and he has this concept of difference, which is the idea that no system of signs can represent the reality it's trying to represent. Partly, and I mean that's part of it in a way. So the best example of this is in terms of language, I think. If you're trying to translate between two languages, there'll always be something missing from your translation. And because different languages capture different aspects of reality, so there'll be words or sentences or ways of saying things in one language that aren't available in the other one. But Derrida thinks this happens. This is the case with all representations. Okay, so so now we have this. This is actually quite similar to this Plato. Plato has a fourfold ontology of the universe. You have the one, which is represented by the logos, or the word. Then you have soul, which kind of interprets the logos. And then there's matter, which is the bits of reality the logos doesn't fully configure. So this, I think, corresponds to the object, the representation, the process, and the difference. I don't think it's a coincidence, because Plato is often taught in terms of his ontology, there's a perfect world of forms out there with everything images, and that's as far as it goes. But a lot of this, I think, for Plato is phenomenological. And that's partly because, for Plato, following the principle, as above, so below, everything repeats itself in different patterns. And the pattern that corresponds to the reality of the universe also corresponds to the human psyche. And this comes out very strongly in Neoplatonists like Plotinus, but I think this is sort of still this is still the case. So the object is like the one, the representation is like the logos, the process, the soul corresponds to the process of understanding the one through the logos, and there's always something that's not fully captured by this, and that is the difference, or matter. So Husserl, I think, is also had a more phenomenological take on this. Okay, so we were talking, so this kind of ties into two things we were talking about earlier. The first thing is consciousness. So this is Augustine of Hippo, the North African sort of Christian Neoplatonist and theologian. And he had this interest, he tries to apply this also in a phenomenological way. So he says we have the one corresponds to the almost Dasein, or somehow our preconceptual awareness of existence. The representation corresponds to our awareness of existence, and the actual process of existing, or of being alive, corresponds to the third thing, or soul. So he sees this triadic structure in consciousness itself, though, I mean, I don't think he has a role for his difference, because he's specifically looking for a triadic structure there. The other thing is, I think, in going back to whether the logos is in itself limiting, this is something I think is very strongly in Derrida. He felt that the logos as a part, I think, of Western science was inherently a problem for understanding the world. I think it only becomes a problem if it's taken out of this structure, because here there's always something new that can emerge through both. So I think I saw this point made by the British writer Mary Harrington, I think following Owen Barfield, and there's the idea there that, in a sense, the Derridian programme is it criticises an earlier Enlightenment programme for wanting to reduce the world to representation, but it itself it rejects this, but it itself sees this as a bad thing. So it thinks that it would be very nice if the world could be perfectly represented, but it's not, and this is a sort of anxiety and general sort of, it's generally quite unfortunate. a better strategy seems to be to consider the fact that no representation can fully capture the world is as partly a good thing, because it means there's always something new that can be brought into any description. And it removes the possibility of a final totalizing stopping point, either human thought or human experience. So, so I suppose the good question is, how on earth does this actually relate to any of the stuff we've been talking about so far? And what I want to say is the explicate order is an image or representation of the implicate order. So the implicate order, by definition, is not fully knowable, because I'm part of the order, and I can't fully know myself. So if I try to know part of the order, I'm still knowing it and having to elude the bits that are interacting with me. Even if I got a full order here, as we saw with the heart in the body, I can't fully understand any part of the order without extrapolating an explicate order from it. And you have this continuum. The more I explicate, the more I understand in some respects, but the more I lose in other respects. And so we can see the explicate order as an image or a representation of the full underlying process. And so the question is, what kind of image is it? So an image is a kind of relation, but is an image a perspectival relation, or is it a dynamical relation? And I think part of the answer is it can be both, but I would say primarily it's going to be I would say that the explicit order in general is going to be a dynamic relation, because if we take quantum physics seriously, if we interact with the world, it's going to change the world as we interact with it. And yeah.
That also reminds me of this, like, Roger Penrose's tree bar.
Okay.
The triangle.
I've come across it. I don't understand it, I think, well enough.
I think very quickly, maybe there's next step. So he said it's impossible to try it.
Thank you. Sorry for interrupting you, because what you're saying is just so nice, but okay. I already did it, so I better just go on with it. So it's an impossible triangle, and in one corner he has matter, which could be like, I don't know if the material world, physics, and in another part he has the Platonic world, and in the third one is mind.
Okay.
And then he says, well, why it's an impossible triangle? It's because, like, some parts of math kind of are connected to thought. Let's say the maths that we do, and we connect it like through thought, and then some of the things we think are connected to the matter world, because not all the models we think about, let's say, are really realized in the matter world. But then we're made out of matter, so we kind of think and connect to something like this. But then he sees like how it's impossible. It's an impossible figure.
This definitely does sound related.
Yeah, because it seems like process could be like thought, maybe. And it would be nice to, if you have a look and maybe...
Yeah, no, I think I definitely will. I mean, it seems particularly related to Husserl, because he talks about how he's interested in phenomenology, so examining the experience of having thoughts. And one of the things he identifies is you have these sort of transcendent processes, so like mathematics, that they're a bit like Kantian a prioris, but he's kind of bracketing what they actually are. He's just saying, if I examine my experience of thinking, there's certain things like mathematics and like sort of causality and like spatiality that I can't get behind. They're just there. So I wonder if that ties into the tribar, if there's the structure of math determines how we can think at the same
time. Oh, maybe. Yes, I don't know.
I don't
know.
Roughly. That's very interesting.
Yeah.
Thank you.
Thank you.
So thinking back about different kinds of images, there's images that are dynamically linked to the thing they're trying to portray, and there's images that are separate. And this brings me on to the final topic. I think we've got about 5 minutes left. So so this is Arianism in absolute space. So this is Isaac Newton, who is famous for his theory of absolute space. And again, I should explain what exactly is going on here. So Arianism is a sort of theological theory about the relationship between the Father, the Son, and the Holy Spirit. The orthodox interpretation is the Trinity. So we see here there is one God, there are three persons. There is only one God, but the three persons are not identical. Quite how you go about understanding this is difficult, and sort of one alternative viewpoint was Arianism, which basically says the Father is not the Son. So Christ is not divine, but is a perfect image of the divine. And Newton was a keen theologian alongside his physics, and he ended up coming to believe in these Arian theories. So how does this relate to what we've been saying? Well, the point is that it's about the imaging of implicate order. Newton famously believed in an absolute space and time. Now, if there is an absolute space and time, this allows you to image physical events by their positions in space and time, and it lets you image them in a way that is purely perspectival. There might be a change in your perspective to those events described, but there's no dynamic change between to do with how the events imprint into the space and time and how we relate to that space and time we are seeing the events through. So, so similarly to how in Newton's Arianism, sort of the Son is the image of the Father, but is distinct and has no ontological sharing, with absolute space, the implicate order is imprinted perfectly onto a separate sort of absolute space and time, which images everything about the implicate order, but is not dynamically related to it. And similarly, because we are also non-dynamically, but only relationally linked to the absolute space and time, we therefore have a non-dynamical, non-interacting, purely perspectival relation through absolute space with any other event in the order. And this collapses the Bohmian structure-process theory, I think, because no longer is the universe a continuously evolving structure. It's the structure which is in principle reducible to a set of non-process, non-dynamic fixed points. It seems to me that if you want to have the Bohmian interpretation of structure process, you need to have a dynamic space-time, which doesn't mean you need a purely relational space-time, but you at least need to have a space-time which is involved in the dynamics of your theory. Okay. Yeah, this is the final thing. The slide. So I should be clear here, I'm not giving an argument, a theological argument for against absolute space. The Trinity could be true and absolute space could be false, or the Trinity could be false and absolute space could be true. I mean, I'm just saying Newton's commitment to absolute space, I think, is at least psychologically similar to his commitment to an Arian view of the Trinity. Interestingly, the final thing to say is I think one of Newton's arguments was that he couldn't see evidence for the Trinity in both the Bible and the very early Christian writings. And the reason why Newman is on here is because Newman, I think, was part of this 19th century idea of process, and he argued that sort of you should expect to see a gradual development. So he said it's clear, if you said to, say, Paul or Peter, what would this diagram mean? They'd probably be a bit confused, but Newman's argument is that this is implicit in the scriptures and the writings of the early Christian writers in a way that only became explicit once you asked certain questions. And I'm mentioning this because I think this is another example of the implicate-explicate sort of duality. You have certain doctrines that are implicate in early stages of an idea that only become explicate as more questions are asked to that idea and as it emerges into new historical and sort of conceptual situations. Okay, so finally, relationality and the dynamic universe. So I think from what I said, it's probably clear. I'm not so sure about I'm not totally convinced by the absolute space present in the dynamic universe. Partly because I'm committed to a view of the universe as being a structure process, and I don't see how this is compatible with a purely absolute view of space and time. I'm also unsure if the dynamic universe does eliminate relationality, because as we saw from Hamish's talk, if it's a perfect sphere, then I can rotate that sphere, and I'll get a equivalent view, a totally equivalent physical description of the universe, but one which is rotated, so it's described differently. So if the slogan is that it's the same universe for all observers, not one that looks similar, I'm still getting an infinite number of descriptions of the universe, but they're now labelled just via rotations of the sphere, rather than Minkowski space rotations. Now, in special relativity or general relativity, as Hamish said, there's a much more complicated set of rotations, and you might be upset about, you might not like the properties of those rotations in terms of removing time ordering, but I don't think you're removing rotation, you're not removing the issue of there being multiple descriptions of a single reality by dropping to a sphere. You're just taking a different set of rotations, and in my opinion, one that are less compelling for other reasons than the ones that we find in general relativity. Now, having said that, I think the strength of the dynamic universe approach is, going back to the very first slide, the distinction between the perspectival and dynamical relationality. So, general relativity gives an account of gravity, which, as you say, is purely perspectival. It doesn't explain why space and time change as I move around the manifold. Like, why does time go more slowly, sort of in a moving frame? Why does energy bend space-time the way it does? I don't know. GR tells me it happens, but I don't think it gives a clear answer as to why it happens. And so, if you want a theory of quantum gravity, given that quantum mechanics involves these dynamical relations, a theory of quantum gravity would have to give a dynamical account of how space and time change in response to interaction. And this is something that GR does not provide, and it's something that I think the DU approach is trying to provide in terms of this energy balance. And to me, the energy balance makes a lot of sense. I mean, if you think about GR, we have that if we take the trace, we get that R is the scalar curvature is proportional to the trace of the stress energy tensor. And so in GR, as I think you point out in one of your papers, you also get this balance between sort of somehow the geometrical or gravitational properties and the energetic properties. So I think this is so my thought is this is a very powerful point, and the search for a dynamic approach to gravity, I think, is exactly the right one to do. I'm somewhat less convinced that the way to do it is by dropping the Minkowski stuff and then going back to a sort of free sphere view of the universe. But yeah, this thing I think is seen very. But the fact that there is an energy balance already there in gravity, I think, is important, and I think that is something that's definitely worth exploring. Well, that's the end of the talk. So.
Very nice. Thank you very much. So,
Now
so
that
we have some time for
this
questions.
here, can I keep it? Yes.
Yes, Marilu,
No.
next to you, or is she first?
Going back to your Trinity.
Yes.
Then again, right? Again, Roger's impossible triangle, because he also has this mind, like a physical world and Platonic world, and it's like you cannot go from one to another.
That's very interesting.
And then it's kind of funny, because when I saw that, I said, maybe if you look at it from the right perspective, it's not impossible anymore.
That's very interesting, because
and I told him maybe something is missing, and in my mind it was like consciousness.
It is, because the tribar is the thing that I think Basil is a fan of it. Geometrically, it looks something like that, right?
Exactly, yeah.
Yeah. Yeah.
It's the thing which you got from Escher.
Yes. So yeah. So, I mean, I'm inclined to think that what's happening with the link would be with this sort of thing here, because I think that I have to think more about it. But it looks like somehow you're going to get the world, mathematical structure, and the art of physics and math are going to form one of these triads. And of course, your difference comes from the fact that even a perfect theory can't capture the fullness of the world. And I wonder if this is what's behind the tribar thing. And then, you know, if you, I think, are a Christian, I want to say that the reason the world looks like this is because this is the nature of God who made the world. If you're not a Christian, you'd probably say, in a Feuerbackian sense, this is like an idealization of this process whereby when the difference kind of goes to zero. But yeah, I reckon that's what the link is, I wonder.
Yes, and another way to see it, if you don't want to take a religious perspective or something like this, you can think about, so that the universe is the whole, and because we're limited, it's impossible that you actually just see it from the perspective where everything is connected. No, we're more like in this triangle, in the edges of the triangle, where where things are impossible in a sense. And
yes.
For me, the way I see that is like this impossibility of actually capturing everything that's in the universe. But in a way, it's what you said before. It makes it beautiful because it means you can always find more, and it keeps us busy. Thanks.
Yeah. So a very quick. So thanks a lot, because this makes one of those connections that we were wishing and fostering during the panel. And I just wanted to share an information that I got from Chris after the panel about the work of Karen Barat. Because she was, Derrida was one of the philosophers they were considering starting from, and they precisely make the same point that you made. So I've been reading while just after the panel. And so I think that this is a wonderful thing, and also I wish to take occasion to say that when we speak about all these philosophy-like ideas, very rarely women are in the game, even though they are, as Chris pointed out. And this, in my opinion, is one of the reasons why physics is not doing so well in these days. could do much better.
Can I add something just because the box is here? We're here. I loved what you did. I loved your talk. And I would say we should have a talk like this in every physics conference.
Absolutely.
Because, sorry? Yeah, because it's like, I mean, it was just lovely. What you did is just, okay, we're all talking about these models, blah, blah, blah. And you put things in this perspective. I mean, I saw your talks. They're so mathematical. I love them. I'm a big fan of what you do. But it's amazing that they say, oh, don't be so mathematical because they're... And you just make this beautiful philosophical stuff, you know. And it just, I don't know, brings things into another dimension. And I would love it if we made a point of having more of these discussions being part of our physics.
Well, thank you.
Yeah, I'm not sure I should really even try to follow that, because I passionately agree with everything that Yvette just said. And thank you very much, Calum. It was a wonderful talk, covering an enormous amount of ground. Just to say very quickly about the tribar, there is, of course, one specific context connected with the tribar, and Roger often says it's actually the reason he introduced it. But the more I think about this, the more I see there is, in fact, a connection with what we've just been talking about, the kind of grander narrative about static being versus arena, dynamic versus perspectival forms of relationalism. That's in the background, but the specific context, of course, in which he introduced the tribar was in trying to introduce the idea of cohomology to people at a very kind of non-technical, very simple level that could be motivated in terms, very intuitive terms. just in terms of looking at this figure. This figure is globally impossible in Euclidean space. And yet it is here, drawn in Euclidean space, but we see its impossibility in the fact that you could not have this relationship between the vertices of the figure in our space. That's precisely because it does carry the first sort of non-trivial cohomology group of the space. So there are obstructions to the existence of inverses of maps, which is precisely what means that you can't put all those bits of the figure together. There's a relationship between the local and global structure of the figure, which couldn't hold between a figure in our space, because our space does not have this kind of non-trivial cohomology. E3 doesn't have that. But although that's a technical issue, I do think that in a way that carries the shadow of some of these deeper, even theological issues that you're talking about. Because they all turn at the end, really, on relationships between locally and globally defined notions. Even perhaps the very notion of entity itself, whether it can be globally and locally defined. One thing which occurred to me when you were talking about the theological background is that the great mistake which I'm not myself a religious believer, I mean it is a fundamental mistake, it seems to me, to think, if we can form any conception of the theos at all, but to think of God as one entity amongst others is a fundamental and complete and categorical error.
Yes.
If there is any conception
yes.
of God to be had, it is
Yes.
not that of one entity amongst others.
Yes.
And there's a shadow of that's going on here in this connection with the tribe. But I think I've already expressed myself in a sufficiently confused way. I just want to say thank you again for a wonderful talk. We couldn't have ended the meeting on a better note, on a better talk.
Yes, yes, thank you. And I say briefly a couple of things. Maybe we can discuss them over in the as we're moving on. But just about the Bohm's, I've been looking into some of the early formulations of Bohm on the implicate order, and of course in the very early papers he already talked about this kind of reflective functions where each part of the universe reflects the whole, light being the best example in the sense that the movement of light waves in any single area contains information about the whole. But then actually in the wholeness implicate order, chapter 6, appendix, there is this thing about where he talks about extending the principle of relativity to the implicate order. And that there he's saying, yeah, usually we think of the implicate order, the hologram. So the interference pattern in the plate is the implicate order, and the image, the three-dimensional image, is the explicate. But Bohm says that we could equally well reverse that and say that from the perspective of the plate, it's the interference pattern there that is, if you like, the explicate, and the image is the implicate. It only comes if you shine light on it. And so this is interesting also so in a way everything is representing everything else, perhaps in the way, and there's a kind of relativity there, which of course makes things a little bit difficult to understand, but anyway, but maybe this is just a mistake. Yes, absolutely. Leibniz is definitely there. It's the monads. But now I think we have to quickly get out of here. Let's thank Calum once more. There are some new people.
Thank you so much.
We are now going. Everybody is invited to the philosophy department, and we can meet outside. There will be refreshments there.